So for this problem, I'm going to be doing an analysis of utilization of a constrained resource. And so we are talking about differential analysis, the key to decision making. And in this particular problem, as I said, it's utilization of a constrained resource. So what we're doing in this one, we've got the selling price, and we've got variable expenses, direct materials and other, and we have a contribution margin and a contribution margin ratio that is given to us. And then we're told that the demand for the company's products is very strong, with far more orders each month than the company can produce with available raw materials. The same material is used for each product. The materials cost $3 per pound with a maximum of 5,000 pounds available each month. So the constrained resource is a direct material that costs $3 per pound and 5,000 pounds are available each month. And they tell us that the problem is they don't have enough to meet the demand for all of their products. And so when we have a constrained resource like we have in this problem, then what we want to do is figure out which product would be best to make when there's a constrained resource. And so I'm going to enter some of this information for you so that you have it in front of you. And then contribution margin. And then I'll add a few lines there to make it look better. And then finally we'll have our contribution margin ratio. Okay, I went ahead and entered some of the numbers, but I wanted to talk about these. Again, hopefully at this point in the course you're becoming very familiar with terminology like variable and fixed. And so on this, in this cell, I'm just going to add up my total variable expenses. And then again, you should know what contribution margin is. It's your selling price minus your variable expenses. So we have our contribution margin, and then our contribution margin ratio is the percentage of the contribution margin of the sales price. And that's a percentage because it's a ratio. That's the way we talk about that number. And I'll go ahead and carry that formula across. So that's the information given to us in the problem. So the first thing we're going to do is calculate for each product. We have three products, product A, B, C. And the first thing that we're going to do, remember our constrained resource is our direct material. It could be labor, it can be anything, it can be space. But for this particular decision that we have to make, it's direct materials. And because the constrained resource is direct materials, we're going to do contribution margin per pound. That's how we're going to analyze this problem. So, for product A, we need to get our contribution margin per pound. And we're not really told exactly how many pounds are in each unit, but we can figure that out. So we can come down here, or actually we can come over here. I'll just do it over here. And we have, actually what I'm going to do, rather than trying to recreate this whole thing, I'm going to calculate the cost per pound, and we know that direct materials cost $3 per pound, correct? So I'm just going to enter that number there, and then I'm going to come up with my pounds required per unit. Now, the way I know that is that my direct materials per unit are $24. And if I know it costs $3 per pound, then I can divide by 3, and I can come up with my pounds required per unit. And that is not a percentage. That is a whole number with no decimal places. And I should be able to carry that over. And I used my absolute cell reference with my dollar sign so that it would calculate that correctly. And then I can do my contribution margin per pound. So in other words, for every pound of direct materials we use, what is our contribution margin? And that's what we're looking for. We're looking for that high amount. So our contribution margin per pound is our contribution margin per unit divided by the number of pounds required. And again, that's a whole number. It keeps picking up my percentages. And I'm going to go ahead and make that a dollar amount so you can see that. So you can already see that product C has the highest contribution margin per pound. So I can already tell that if I have a constrained resource, I'm going to make as much as C as I can. So the question says in part 2, which orders would you advise the company to accept first, those for A, B, or C? And so I'm looking at B and I'm seeing, okay, first of all, it uses the least amount of pounds, 3. It's the most profitable of the 3 in terms of materials. And so we see that and we're like, okay, well, that makes perfect sense. However, I want you to look at product A. It requires 8 pounds per unit. The contribution margin per pound is $4. Now look at B. Use 5 pounds, contribution margin per pound is $2.80. So just kind of think about what we're looking there at for just a minute. So I'm just going to go ahead and move, these are my calculations, I'm going to move my answer down here. That one is $4, $2.80, and $7. So the question again says, which orders would you advise the company to fulfill first? And so we're going to do this first. It has the highest contribution margin per pound, this one second, and this one third. So again, what we're doing is we're looking at what is the constrained resource, and this one it's direct materials, and then what is the contribution margin per constrained resource. And then with that we can make a decision. And that's again what this chapter is about, making decisions based on a differential analysis.